In section 7.7, we're looking at solving right triangles. So before we can solve right triangles, we actually have to look at our last ratios, and those are our inverse trig ratios. To start off with those, we're going to have inverse sine, inverse cosine, and inverse tangent. They're still within a right triangle, and we're still focusing on angle A. So we're going to say that if sine of A equals y, and this goes back to when we first introduced sine, that we know that y is some ratio, and in this case that sine ratio would be the opposite leg over the hypotenuse. But if sine of A equals y, then we have that sine inverse of y equals the measure of angle A. So what it looks like in first glance is I've switched this y and this A. I've gone from sine of some angle equals a value to the inverse of that, sine inverse of that value equals the measure of angle A. And it's a sign of things to come that we're going to be able to now to take this ratio and find the actual value of the angle. It also works for cosine, so if cosine of A equals z, we'll say, and that's just some value, some ratio, then cosine inverse of z equals the measure of angle A. And finally, if tangent of A equals a ratio x, then tangent inverse of x equals the measure of angle A. So let's give it values in our triangle and actually start to work through and see how this is actually something very useful for now finding angle measurements. So we have 20 and 15 as the lengths of our legs. We need, well, so far, really the only one we could use would be tangent, because tangent is opposite over adjacent. You know, while we're at it, let's write this SOHCAHTOA up here, just to give us a reminder as we go through, because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now we can refer back to that as needed. But we said tangent was the only one we could use here because we only have the opposite and the adjacent legs. So let's look at those. Okay, so tangent of A is going to be the ratio 15 over 20, which reduces to 3/4. So that matches that first line. So now we say tangent inverse of 3/4 equals the measure of angle A. So now we've taken this inverse of the tangent. So now we can plug this into my calculator, and let's actually take our first look here to see how we put it in our calculator. Hopefully you know how to put sine or cosine and tangent, the regular forms, in already. And if you put the number in, then press tangent, you're going to do the same idea here. If you press tangent, sine, or cosine, then put the number in, you're going to do that same process here. But now we're doing the inverse of them. And if you look, if your calculator looks like mine, I have sine, cosine, tangent, and then I have these little above them, sine to the -1, cosine to the -1, tangent to the -1, and those are my inverse trig ratios. So I'm going to use that here. So I'm going to do shift tan inverse, and then in parentheses, I'm going to do 3 divided by 4. If you didn't want to do it as a fraction, you could have done 0.75, because that's 3/4. Okay, I hit equals, and I don't know if you can see that on your screen, but we get that it is about 36.9 degrees using that. Now, if you're using a different calculator where you have to put the number in and then press tangent, like an iPod or an iPhone, you're going to want to type your number in. So in this case, 3 divided by 4, or just 0.75. Then you would hit second, and the sine or the tangent inverse button would come up. Try it a few times. You know it's supposed to be 36.9 for tangent inverse of this. Try it a few times. Make sure you understand the correct way to get to it. And if your values are way off, make sure you are in degree mode. Okay, so let's get back up here. So now I'm looking at, well, I have 15/20. If I knew that other side, that hypotenuse, I could maybe do sine and cosine. And we could find that by Pythagorean theorem. So that would be AB squared equals 15 squared plus 20 squared. It also is a Pythagorean triple. It turns out, for the sake of time, it turns out to be 25. So now we can say sine of A equals 15 over 25.
Students who are not participating in an extracurricular activity at this time, please report to the front of the school to wait for your ride.
I can reduce 15 over 25, and that is 3/5, or 0.6. Now we take the inverse, and that's sine inverse of 3/5 equals the measure of angle A. If you do that in your calculator, it comes out to be about 36.9. Now, you may be thinking here, I don't have a calculator. How am I going to do this? Well, we can go back to our trig table and look at that. Now, we're looking for, let's say in this value, the sine, I'm looking for a value that's close to 0.6 in the sine column. And if I work my way down, I see right here, I have 0.6018 is 37. Well, I have 0.6, so that's a little bit smaller than 37. It's bigger than 36 because that's 0.5878. So I could say, I'm for sure it's between 36 and 37. Go out there a little bit and say it's close to 37. So I can get a whole number approximation there. But again, 36.9, it is close. It does give a better idea. Calculator is going to be your way to go here. It does give you that decimal more accurately. And seeing that we even did round this off, but you can refer to the trig table just to give you an idea of the values you have. Okay, let's finish up. We have cosine of A equals, that'd be 20 over 25, which is 4/5. So cosine inverse of 4/5, which is 0.8, equals the measure of angle A, and that also comes out to be about 36.9. Now, you're looking, the values are all the same. They should be. We're looking at the same angle. All the inverses that we use do give us the same value for angle A. Would we have to do all three of them for one problem? No, we just find the one that works. For example, we only knew 15 and 20 when we started. That would be the one we'd use, and we could just use tangent as we go. So, now we're looking here. Use a calculator to approximate the measure of angle A to the nearest 10th degree. So I have A in this left one. I need to find, I'm going to use the inverse ratio. Really, my first trick is to pick which one I'm going to use. So, I have an opposite, and I have an adjacent. So that means opposite and adjacent, O and A. I'm going to use tangent of A is opposite over adjacent. So tangent of A is 30 over 20, which is really 3 over 2. So tangent inverse of 3 over 2 is going to give me the measure of angle A. So let's see what we get here. We do shift tangent inverse, 3 divided by 2. You could also make that 1.5 if you needed to. And that comes out to be about 56.3 degrees. So that is the measure of angle A. Look at our second one. I'm looking at A. This time I have an adjacent and a hypotenuse. Look up here, adjacent and hypotenuse looks like cosine. So cosine of A is adjacent over hypotenuse. So cosine of A is 10 over 16, which is really 5/8. So cosine inverse of 5/8 equals the measure of angle A, and that's going to give us A approximately. Let's see what we get here. I get it's about 51.3 degrees. So 56.3 and 51.3. Now, let's stop and think for a second. If I'm going to actually find angle C in these triangles, what I could do is I could do tangent of C, like in this first one, and say 20 over 30, take the inverse and repeat the process. That would help me find angle C. Or, a shortcut we have is we know that the measure of A plus the measure of C equals 90 degrees. Because all three would add up to 180. Well, this is always 90, so really these two will always add up to 90. So you can use that as actually a shortcut. Instead of having to do another inverse trig ratio, I could subtract 56.3 from 90 and get my angle here. I could do the same thing, subtract 51.3 from 90 and get my angle there. That's going to be a part of solving a right triangle, which we're going to do next. But just for finding the angle, there's our examples there. Let's look now solving right triangles. So as we solve right triangles, we're going to be given different information, and we just need to work our way through, and we consider the triangle solved when we know all of the sides and all of the angle measurements. We will always start off with a right angle, and we'll probably have two pieces of information. In this case, I have a side, and I have an angle. First off, it's going to be pretty easy to find the third angle if I knew one of them, because I know that the measure of angle V plus the measure of angle D have to add up to 90 degrees. Furthermore, D is already 50 degrees. Therefore, I get that 40 degrees is the measure of angle V. So, that gives me my angle. Now I need my sides. Let's see, I have DM here, and I have DV. Let's start with DM. I really have two choices to use for DM. I could use 50 degrees.
All staff, please remember to post your attendance. Thank you.
I could use this 50 degrees with the 21 and the DM, which would be tangent of 50 equals 21 over DM. Or I could use the 40 degrees with DM and 21, which would be tangent of 40 equals DM over 21. Either one will give you the correct answer. So, if you see one, use it. I like to make things easier though. And if I look at the one on the right, if I multiply both sides by 21, I get 21 times tangent of 40 equals DM. That's going to be nicer to solve than what this one becomes, which is DM times tangent 50 equals 21, and then DM is 21 over tangent of 50, particularly if I'm going to solve by hand, because I can multiply a lot more nicely than I want to divide with decimal. Either way, we'll look at what our answers we get here. So if I do 21 times tangent 40, and this is not inverse, it's just regular tangent, I get it's about 17.6. And then I go back to my first one, 21 divided by tangent 50, and it is about 17.6. Good, so it matches, so it's the same thing. Did I have to do both? No. Just pick one and go with it. Okay, now I have dv left. What I could do is Pythagorean theorem to solve for it. I could do sine of 50 to solve for it, because I have 21 over dv. Or I could do cosine of 40 to solve for it. Now, I'm more likely, and just in my preference, to do one of these. And that's because sine of 50 is going to be 21 over dv. Cosine of 40 is going to be 21 over dv. In either case, I'm not going to have use the number I rounded off already. Whereas in Pythagorean theorem, it's going to be dv squared equals 21 squared plus 17.6 squared. And why I hesitate to use that one is I've rounded off 17.6. So that's not an exact value. I did an approximate up above. So just out of a matter of preference, I don't necessarily want to use that one. If we're going to one decimal place, it's probably going to be accurate enough. We'll check and see. But really, either of these would use numbers I started with, or whole numbers I know are exact, and I could do those. So if, let's work our way down the middle. We get dv times sine of 50 equals 21, which gives us dv is 21 over sine of 50. The next one is dv times cosine of 40 equals 21, and dv is 21 over cosine 40. Check both of those, see what we get there. So we have 21 divided by sine of 50 gives us about 27.4 for dv. 21 divided by cosine of 40 gives us that dv is approximately 27.4. It's a good sign when they're the same number. That's what we're going for. And over here I get 21 squared is 441. 17.6 squared is 309.76. Let's add those together. And then take the square root. Oops. So we're going to take the square root of 750.76, which comes out to be about 27.4. So we can see dv is going to be 27.4. We found it 3 ways. Do you have to do that? No. But just realize your options are there. Find the way that's going to be easiest for you. So now we look at this next one, another solving a right triangle. So we look at it, what are we going to do first? I know I have an angle. I know the hypotenuse. Well, I can find that other angle. That other angle is going to be 45. Now, do you notice something about it? This happens to be a 45, 45, 90 triangle. So this is one of our special right triangles where we know that the hypotenuse, to get from the hypotenuse to the leg, we divide by root 2, and to get from a leg to the hypotenuse, we multiply by root 2. Now, I'm going from a hypotenuse to leg, so I could divide 12 by root 2 and get both of the legs. Now, it's not just this one. They're the same because it is also isosceles. So if I do 12 over root 2, then I simplify it, I get 6 root 2 for these sides. Now, let's take a minute and realize maybe we didn't notice this. So, let's write 6 root 2 as a decimal. It's about 8.5. So we're going to say we didn't notice this, and we went back and we went to our trig ratios. So if I took 45 and said sine of 45 equals PQ over 12, and I could have done sine of this 45 for that one, or I could have done cosine, but let's just pick this one. And I do 12 to both sides. I get 12 times sine of 45 is also approximately 8.5. So it gave me the same value, but notice it's not in radical form, and that would be tough to figure out what the radical form would be. So using that 45, 45, 90, we can find it a lot faster. On a test, it's probably going to be in radical form, and we need to realize how to identify it when it is a 45, 45, 90. But if anything, what we can at least see is this is a backup. We can go to sine, we can go to cosine. It'll still get us to the answer even though we may not see the shortcut. Okay, we have our last problem here, and probably a good thing, maybe as we get comfortable with these, you pause it and try it on your own, and then see if your answers match up. So, I look at this one first. I have 2 sides. When I have 2 sides, I can find the third side by doing Pythagorean theorem, and that's going to be AT squared equals 16 squared plus 30 squared. 16 squared is 256. 30 squared is 900. That gives us AT squared is equal to 1156, and AT is 34. Okay, so we have our 3 sides. Now we need an angle. So this is going to use the inverse ratios. So our options, we could do sine, we could do cosine, we could do tangent of angle A or angle T. So we actually have the option of doing it for any of them. So you pick one, you solve it. Once you solve it, whenever you get the angle, let's say angle A, we'll subtract it from 90, we'll have angle T. So let's see, which one should we do? How about we pick tangent of A, which is 16 over 30, which is also 8 over 15. And tangent inverse of 8 over 15. And 16 over 30 would also give us the same value in the end here. But tangent inverse of 8 over 15 comes out to be about 28.1. So that's angle A. It's about 28.1. Now, I could do tangent of T, which is 30 over 16. I could do sine or cosine of T also, but we could kind of do the shortcut and say, well, 90 minus 28.1 is equal to the measure of angle T, because this is the measure of angle A. So 90 minus 28.1 gives us 61.9 degrees, which we're going to say is approximately angle T. So we were able to find all the parts. We went Pythagorean theorem and then inverse ratios to get from the sides to the angle.